Hello students, this is Dr. Walker. We're at the lake. It's a great place to introduce our new unit on water resources. We're at Heartland Community College at Birky Pond, which is a water detention basin, which basically means that it collects all the flood water after like a major rainfall, and it prevents flooding of the campus and the areas around here. In the fall, we usually come out here and kick our school year off by doing a tour of Heartland Community College, which is out there in the distance. But also, we'd do some science out here where we learn to determine the water quality of a body of water. And so, when we are evaluating the water quality of a lake or a water body, we use a protocol established in 1970 by the National Sanitation Foundation, where they look at 9 different parameters or 9 different factors of water of a lake. And so these factors are temperature, pH, turbidity, total solids, or we call it total dissolved solids, dissolved oxygen, bio-oxygen chemical demand, or BOD, total phosphates, nitrates, and fecal coliform. And so to determine how good this water quality is, we would have to run tests on temperature. But it's not just temperature, but it's change in temperature between 2 places on the lake. So essentially what I would do is I would use a thermometer, which I have in my instruments here. Here I have a water quality meter. It's called a YSI water quality meter. And one of the things it measures is the temperature of, say, the water. And so to find out, to do my first measurement, I would press my mode button on here and bring up a screen that shows temperature. It's rather cold today. It's showing that right now it's 2.6 degrees Celsius, which is essentially the air temperature out here. And so to find out the delta T, which is the temperature, the difference between 2 spots in the lake, I would throw my probe into the water. I would record a first temperature. Then I would, after that, I would walk about 10 yards, throw it in, and measure a second temperature. And delta T is essentially the difference between those 2 temperature values that I determined. So now I'm going to go out in I'm going to throw my probe into the lake. The temperature in that spot is the temperature in that spot is 1.2 degrees Celsius. So I'll make a note of that. And then I will walk about 10 yards. I'm going to go 10 yards to the north, and I'm going to put my probe in the water again and see what the temperature is there. And so my second reading is 1.1. And so I'll record that second reading on my data sheet. It's 1.1. And so in my chart, to find delta T, it's going to be 1.1. I'm going to subtract 1.1 from 1.2. So my result is 0.1. So my delta T is going to be 0.1. Okay, so the next variable I'm going to measure is the pH of the water. Recall that in our in Unit 2 we talked about pH. It is a measure of acidity or basicity of water, and so we recall the pH scale: 0 to 14. 7 is the neutral point. Less than 7 is acidic, and greater than 7 is basic. And so we can use a pH probe, which looks like that, to measure the pH of the water. We might have to go out and get some water first, and then this is hooked up to a interface like my iPhone or a LabQuest in the lab, but I'll be using the iPhone for this. And so basically, I get some water. I uncap my probe here, rinse it off with some distilled water, and then put it in the water to test the pH. Probe. My old-fashioned scoopler to get some water out. Then I simply put my pH probe in my water, and since I'm using the same device to measure to film as I'm going to be using for my pH, I'm going to pause and I'll come back and tell her what the pH is. As it turns out, the pH of my water was 6.76, which would indicate that it was slightly acidic. Okay, the next thing I'll measure is the total solids. We also call it the total dissolved solids. It's a measure of all the minerals and all the ions and all the pollutants and contamination that is dissolved in the lake water. Typically, we want that number to be below 500 milligrams per liter. And so we're going to be using our YSI 85 water quality meter to measure that. The probe is in the water, and it is telling me that my total dissolved solids is 569 microsiemens, which is a unit of conductivity that we convert to milligrams per liter by multiplying by 0.6, and so it will come out to about 340 milligrams per liter. The next thing we will be measuring is the dissolved oxygen levels in the lake. Now, like all living things respire, and they need oxygen for respiration. So in the lake here, we have to have some dissolved oxygen, so the fish and other aquatic species can survive. And so we want that levels to be close to about 100% saturation, somewhere between about 6 milligrams per liter and about 6 to 10 milligrams per liter of oxygen dissolved in water. And so I'm going to use my YSI 85 water quality meter to actually measure that as well. So I press my mode button, and I want to bring up where it says percent. That percent is actual dissolved oxygen percent. And it's telling me right now that my dissolved oxygen in the lake is relatively low. It's about 29.0. All right, now it changed. The wind is blowing, so it changes. It's 28.8%, which is rather low for a lake. The issue right now is the lake is partially frozen, and so it might have something to do with the fact that it's covered with snow and ice, and there's the diffusion of oxygen from the atmosphere is not occurring. Another aspect of water quality is fecal contamination. This is a source of biological pollution where fecal matter from animals, whether it be birds or other animals around, enter the water and cause the proliferation of bacteria. The bacteria that we use as an indicator is coliform bacteria. And so in our water quality study, we are going to perform a coliform bacteria test on our water. And so we buy a plate that is specialized to test E. coli and coliforms. And basically what we do is it comes with 96 plates already with a testing material. And what we're going to be doing is we're going to be adding water, about 3 to 5 milliliters of water to each well plate. So all 96 wells are filled up. We put the lid back on our media, our testing media, and make sure it's tightly placed, matches up. And we put it in a Ziploc bag. And then we place it in an incubator for 24 hours. So the incubator is over here in our fume hood. Okay, the next step is to remove the plates from the incubator, and now you are looking for the number of wells that has a blue color. And in our case, there are 7 wells that have indicated blue, which means there are 7 wells that are tested positive. And from that number, we use the most probable number of coliform bacteria, a table, to determine that there are at least 19 colonies per 100 milliliters of water, not 19 colonies of coliform bacteria per 100 milliliters of water in our sample. The next aspect of water quality that we will be measuring is turbidity. Turbidity, as we've discussed before, is how clear the water is. A water body that is absolutely crystal clear would have a turbidity of 0. Any cloudiness in the water would indicate some level of turbidity ranging from 0 upwards to above 100 NTUs of turbidity. So we use a turbidity sensor hooked up to a LabQuest unit to measure the turbidity of our lake water. And so I brought a sample of water back to the lab and placed it in a valve and calibrate my turbidity sensor, and now I'm ready to measure the turbidity of my lake water. Simply match the vial, that little triangle on the valve, to the triangle in the sensor, and look at my screen, and I have turbidity at about, and it's still moving, so I'll give it a little bit of time to calibrate. So so I'm going to ballpark it. It's around 5 NTUs. The next aspect of water quality that I will be determining from my lake water from Birky Pond is the nitrates level. Now, nitrates comes from fertilizer runoff, primarily around here. Nitrate is a component of fertilizer that farmers all around the country uses to improve the nitrogen component of the soil. Unfortunately, some of that nitrate fertilizer, after a rain event, runs off into water bodies, including streams and lakes, and increase the nitrate levels that can lead to things like algae bloom, and later on fish die off through a process called eutrophication. And so to determine the nitrate levels, we're simply going to follow a series of steps in our nitrate kit. And the first step there says fill the test tube to the 5 milliliter line. So I have a vial here in my test kit. There's a line there that is marked 5 milliliter. I have my lake water that I've put in one of these old distilled water bottles, and I'm going to put 5 milliliters of water in there. This is my first step. Then the next step is to add nitrate test tab number 1. And so there's these little tablets that come with the kit. So you add that, and then you cap it, and you shake it until the tablet disintegrates. All right, so our tablet, test 1, has disintegrated. And then the next thing, we add test tab number 2, another tablet. Test tab number 2, cap tightly, and also put it in our protective sleeve and shake for about 2 minutes. And then we're going to wait for about 5 minutes for the nitrate test to be completed. So we leave this in here for 5 minutes, and we'll come back and look at it in a couple minutes. Okay, so we're back to check on our test. So basically, now we're going to match the color of our solution here, our nitrate test solution, to the color on our card. And it kind of comes out to about 5 milligrams per liter of nitrates in our water. So it matches there to about 5. The next test I'll conduct from our water quality study of Birky Pond is phosphates. And so phosphates, like nitrates, come from the fertilizer runoff in our area. Other sources of phosphate would include things like detergents that were the use of phosphates in detergent was banned years ago to protect our streams. But like nitrates, phosphate also leads to algae bloom and eutrophication. And so we're going to be testing our phosphate level using our phosphate test kit, just like nitrate. Comes with a series of instructions on the back, and we have some test tab. In this case, we'll have one, and we start with putting 5 milliliters of water in our vial. So we have a test vial there, and the first step is to add 5 milliliters of our lake water. Again, I have it in a distilled water bottle just because it's easier to manage that way, as I brought it back from the lake. And so there's my 5 milliliters of water. This is add 1 phosphorus test tablet, and here it is, my phosphate test tablet, and it says cap cap the tube and mix until the tablets have disintegrated. So we're going to do the same thing here. We'll mix. Then we're going to wait for about 5 minutes. Okay, so our test results for our phosphate test. This is our color. We match it to our chart, and our phosphate levels is around 4 milligrams per liter. So 4 milligrams per liter is our phosphate level as matched with that dark blue indicator. The biochemical oxygen demand is another aspect of water quality of a body of water. This is a measure of the amount of organic matter present in the water. The more organic matter that is present in the water, the higher the bacteria activity and the less of dissolved oxygen that we have. So this is an important measure. It typically takes 5 days for this measurement to be determined in a lab situation. And that's what's actually called 5-day BOD levels. And so because of its complexity, we usually just use an average amount, an average value in this lab. And the average value is approximately 5.2 milligrams per liter. Finally, we have compiled all the data we need to determine the water quality of the water at Birky Pond. The next thing we're going to be doing is using our Q value charts. We're going to be converting the results to Q values. Then we'll use the weighting factor to calculate the subtotals. We'll then add up the subtotals to get a score. And from the score, we will determine the quality of the water using the water quality index rating at the bottom of the page.